Okay, so let's take a look at an example. This is practice quiz 3, question 2. It says, over the holiday break, a student carrying the flu returns home to a small isolated town with 5,000 residents. Suppose that the rate at which the virus spreads is proportional to the number of people who are infected times the number of people who are not infected. So after 1 week, 100 people have become infected. So the question is, how long will it take until half the town has been infected? So you can assume the flu maybe is coronavirus or something, who knows. Okay, so let's start answering this question here. So first let's define x of t to equal number of people who are infected at time t. Okay, so again, x of t, number of people who are infected at time t. Since it says after 1 week 100 people have become infected, let's assume t is measured in weeks. So we're going to assume t is measured in weeks here. Okay, so again, measured in weeks, or t here. So we're given time 0, well, there's one person coming back to the town. So x of 0 then would be 1, and after 1 week, so x of 1 then would be 100 people, so it would be 100. Okay, so let me write that here. So again, x of 0 would mean at time 0, so at time 0 you got that one student returning home, he has the flu, and then 1 week later 100 people have the flu, so x of 1 would be 100. And we're also given here that the virus spreads is proportional to the number of people who are infected. So the spread of the virus would be dx dt. That's how the number of people who are infected is changing. So we'd have dx dt proportional to number of people who are infected times number of people not infected. Okay, so let me write that here. So we'd have then dx dt equal, so proportional to number of people infected, which is x of t, I guess, I'm just leaving up to t, times number of people not infected. So if x is number of people infected and there's 5,000 people in the town, then 5,000 minus x would be number of people not infected. I'm also assuming here when the student returns to the town, the population's 5,000. Okay, so we have this then, so we have these things. Alright, so let's keep going. Okay, so the next thing to notice is that this guy is actually a separable differential equation. So let's take all the dx's and x's to one side and all the dt's and t's to the other side. So doing that we get then, okay, so again it's separable, so therefore dividing both sides by x and 5,000 minus x, bring it over here, and multiplying both sides by dt, you'd have then this dx over x times 5,000 minus x equals k dt. Okay, so we're going to have to use partial fractions on this side, so I'm out of space here, so I'm going to erase a few things and we'll keep going. Okay, so summarizing what we have to here then. So we're going to have to find the partial fraction decomposition of this guy in order to, because we want to integrate both sides here. So we're first going to have to find the partial fraction decomposition for this guy. So it's going to be a over x and b over 5,000 minus x. Our job now is to find a and b. So let's multiply both sides here by x times 5,000 minus x. So doing that we get then, so again multiplying both sides by x times 5,000 minus x. So here these will cross off, here x's will cross off, here the 5,000 minus x will cross off of this guy. So simplifying we get then, then 1 equals a times 5,000 minus x plus bx. So we can choose x now to be any values we want. So let's first choose x to be 0. So choosing x to be 0 then here, we can find a. Okay, so doing that. Okay, so putting 0 in place of x here and here, we'll have 1 equals a 5,000 minus 0 plus b times 0 at 0. So we can solve for a then. Looks like a will be 1 over 5,000. Okay. Okay, so a is 1 over 5,000. So next we can let x equal 5,000, and then we'll be able to find b. So putting 5,000 in place of x here and here, we get then. So we're choosing x to be 5,000, so putting 5,000 here and here. So solving it out, then b is 1 over 5,000 also. Okay, so now let's write out our partial fraction, guys. So our a is 1 over 5,000, our b is 1 over 5,000. So then, we get this then. So I'm putting 1 over 5,000 in place of a and b here, then factoring out the 1 over 5,000 in front. So it'll be 1 over 5,000 times 1 over x plus 1 over 5,000 minus x. Okay, I'm now going to substitute this guy here, up here then, in our differential equation. Okay, so again, this guy will go up here. Okay, so doing that then, I have to erase a few things now, so let me erase a few things here. So making that substitution, we get then this then. Now we're going to integrate both sides. So let's do that. So integrating both sides, I pull the 1 over 5,000 out, and using the linear property of integrals, it means I can do integral of first guy plus integral of second guy here, then integral of this guy over here. Now the integral of 1 over x will be just ln of x here, and the integral of this guy, we're going to make a u substitution. We're going to let u equal 5,000 minus x. So we're going to let u equal 5, so be 5,000 here, 5,000 minus x. So then du dx would be minus 1, so du would be minus dx, or dx would be minus du. So making those substitutions over here, we get then. So we have the integral of 1 over x again, ln. Making the u substitution here will be integral of 1 over u times minus du equals integral of k dt would just be kt plus some constant. And this minus sign you can bring out in front here, and this would be minus ln of u, but u is 5,000 minus x. So let me write my answer here. So we get this then. Let's multiply both sides by 5,000. So doing that, we get then. Okay, so multiplying both sides by 5,000, we have ln of x minus ln of 5,000 minus x equals 5,000 kt plus 5,000 c. I'm going to call the 5,000 c c1 and the 5,000 k k1. Let's call this guy c1. Okay, that one's c1, and let's call this guy here k1. Okay, so like this. Now let's use some properties of logs. So we're going to use the ln of a minus ln of b equals ln of a over b. So apply that where the a is x and the b is 5,000 minus x. So applying it here, then we get right over here, we get then the following. So we get then the ln of x over 5,000 minus x equals k1t plus c1. Now let's exponentiate both sides with base e. So doing that, we get then. So we get this then, and let me break this down a bit further. So you can break up like this, and let's call the e to the c1 guy right here, let's call that c2. So like this. And now the e and the ln will cancel here. So let me write out what we have then. After simplifying this, we get then. So we end up with then x over 5,000 minus x equals c2 e to the k1t. Now we want to find C2 and K1. We'll be able to find those using our initial conditions. So we had a time 0, so x of 0 is 1, and x of 1 is 100 here. So let's use those to find the C2 and the K1. So I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we have this. Now again, as I mentioned, we define the C2 and K1. Let's use the x0 being 1 first. So we're going to put 0 in place of t and 1 in place of the x here. So doing that, then we get this. Again, I'm putting 1 in place of the x here and 0 in place of the t over here. So e to the 0 is 1, so it looks like C2 then will be 1 over 4,999. So the C2 is 1 over 4,999. Next, we're going to use now x of 1 equals 100. So we're going to put 100 in place of x here, 1 in place of t here, and we'll use our C2 value here. So doing that, we get then. Okay, so again, I put 100 in place of the x here, and I put 1 in place of the t here, and I put my C2 value as 1 over 4,999. So I got this guy over here. So simplifying this a bit, we get then, okay, we get 100 over 4,900, cross off 2 zeros, so it'll be 1 over 49 here. Let's multiply both sides by this guy, so doing that, so basically solving for the e guy. So doing that, we get then, okay, so solving for e, we get e to the k1 equals 4,999 over 49. Now let's take ln on both sides, so doing that, we get then, okay, so the ln of e to the k1 is just k1, and you can check in your calculator if you do ln of 4,999 over 49 is roughly equal to 4.625, okay? So if recall, our objective was to find how long it takes for half the town to become infected. So half the town would be 2,500 since the population of the town is 5,000. So let me write that here. So we need to find t such that x of t is 2,500. So we're looking for that t value. That would be half the town being infected. So we're going to put, in place of x up here, we're going to put 2,500 here and here, and then solve for t. Okay, so again, I put 2,500 in place of x here and here, and I got this then. I'm going to keep writing it as C2 for now and K1, even though I've found those values, just for ease of notation for the moment. Now 2,000 divided by 5,000 minus, sorry, 2,500 minus, divided by 5,000 minus 2,500 is 1, so we got 1 on this side. So again, this guy's 1. So dividing both sides by C2 then we'll have 1 over C2 equals e to the K1t. Now let's take ln on both sides. So doing that, we get then, we get this then, and the K1t guy can come in front, and ln of e is 1, so it's going to be K1t here, and this would be ln of 1 over K2, so let me write it over here. So we have this then, I'm writing the 1 over C2, C2 to the minus 1. Then we can divide both sides by K1 to solve for t, so doing that we get this then. Now we can plug in our values. So our K1 we're using as this, and our C2 is this. So plugging those guys in here, we get then. So plugging our values in. So C2 to the minus 1 then would be 4,999. Our K1 was 4.625. And when you work this out, it turns out to be roughly equal to 1.84. So in 1.84 weeks, pretty much half the town would be infected. Okay, so we're done. So you can see it really spread quickly, because after 1 week, it was only 100 people. But yet after less than 2 weeks, half the town was infected. Alright, so let's leave it there.